Let's talk about how to perform and describe rotations, which is taking a figure and turning it around a point for a certain number of degrees. In order to perform a rotation, you have to know those two things. You have to know the point that you're rotating around, which is just called the point of rotation, and you have to know the number of degrees that you're rotating and in which direction. I'll be using abbreviations of CW and CCW for clockwise and counterclockwise, and for our purposes in this class, we're going to be limiting ourselves to rotating around the origin for our point of rotation and to increments of 90 for the degree measures that we'll be rotating. So we could rotate 90 degrees, 180 degrees, or 270 degrees. After 270, of course, comes 360. 360 is full circle, which means it wouldn't move at all. And there are a variety of ways to perform rotations, but the easiest way is just to memorize these rules. If you're rotating 180 degrees, you change xy into negative x, negative y. If you're rotating 90 degrees clockwise, then you change xy into y, negative x. And keep in mind that a 270 degree counterclockwise rotation is equivalent to a 90 degree clockwise rotation. And if you're rotating 90 degrees counterclockwise, then you change xy into negative y, positive x. And keep in mind again that 270 degrees clockwise is the same thing as 90 degrees counterclockwise. So as long as you memorize each of these three rules, rotation should be pretty easy. Let's take a look at an example. We're going to rotate triangle ABC 180 degrees clockwise around the origin, which, by the way, for 180 degrees, you don't really have to say clockwise or counterclockwise because it would be the same thing either way. The rule for rotating 180 degrees in either direction is to change xy into negative x, negative y. So since A was the point 3, 6, A prime is going to be the point negative 3, negative 6. All I did was change the sign of the x and the y. B would become the point negative 2, negative 3, and C would become the point negative 9, negative 4. Plotting these points will result in this transformation, rotating triangle ABC 180 degrees clockwise. A prime is the point negative 3, negative 6, B prime is the point negative 2, negative 3, and C prime is the point negative 9, negative 4. Let's try another one. This time we're going to rotate triangle DEF 90 degrees clockwise around the origin. The rule for rotating 90 degrees clockwise is changing xy, remember xy is the coordinates of your preimage, and transforming that into y, negative x, which means we need to change the sign of the x value and then switch the order of the x and the y. So instead of a positive 2, I'll have a negative 2, and I'll switch the order. So D prime becomes 9, negative 2. Same thing for E. I'll make the x value negative, so that's a negative 3, and I switch the order, so that's 4, negative 3. And the x value of F also becomes negative, and I switch the order, so I have the point 3, negative 10. Plotting these points results in this transformation of rotating that triangle 90 degrees clockwise. So D prime is the point 9, negative 2, E prime is the point 4, negative 3, and F prime is the point 3, negative 10. So as you can see, as long as you know the rules for each of these rotations, you just change the coordinates accordingly, plot them, and you're done. So let's try another one. This time we're going to rotate 90 degrees counterclockwise, which means the rule that I'll use is xy becomes negative yx. Now our y value already is negative. It's a negative 2, but I need to make it the negative version of negative 2. Well, a negative negative is a positive, so this is really positive 2. And I have to flip around the order so that I have negative y, positive x. So that becomes 2, 3. Same idea for h. The y value is already negative, so if I need to make it negative, that's a negative negative, so it's a positive. And then switch around the order, so h prime is 8, 4. And same thing for I, make the y value negative and change the order. So performing this transformation, I would rotate 90 degrees counterclockwise and get these points for my image. Since we're limiting ourselves to rotating in 90-degree increments, you can actually think about it like rotating by quadrants. One quadrant is equal to 90 degrees. So if you think about this coordinate plane like a clock, clockwise goes in this direction, counterclockwise goes in this direction. So for this transformation, we were supposed to go 90 degrees counterclockwise. So it makes sense that we ended up in quadrant 1, because we started down here in quadrant 4, and if I go counterclockwise 1 quadrant, that lands me up here, as opposed to our previous example, where I went 90 degrees clockwise. So I went in this direction 1 quadrant away, and that's how I got to quadrant 4 from quadrant 1. And for our first example, we went 180 degrees. Well, that's 2 sets of 90, so I went 2 quadrants away. So I went from quadrant 1 to quadrant 3. Let's try another one. This time we're asked to rotate 270 degrees counterclockwise. Well, counterclockwise is this way, the opposite of the way the clock goes, and 270 is 3 sets of 90. So I'll go 3 quadrants away counterclockwise. So I'll go 1 quadrant, 2 quadrant, 3 quadrants away counterclockwise, that's 90 degrees each for a total of 270 degrees of rotation, and I end up right here. Well, that would be the same thing as rotating 90 degrees clockwise. Just 1 quadrant away in the opposite direction is equal to 3 quadrants away going counterclockwise. So the rule that I'm going to use for 270 counterclockwise is the same thing as the rule for 90 degrees clockwise, which is y negative x. So I'll make my x value negative. It already is negative, so that's a negative negative, so it's a positive. And I'll switch around the order. So j prime becomes negative 2, positive 4. Change the sign of the x value of k and switch the order, and I get the point negative 8, 1. And again, change the sign of the x value of L and change the order, and I get the coordinates of L prime. Performing this transformation would look like this if you think about it as a 90-degree clockwise rotation instead of 270 degrees counterclockwise, because those things are really the same. Alright, I want you to pause the video and try this next one on your own. Let's see how you did. This time I'm rotating 180 degrees, counterclockwise or clockwise. It actually doesn't matter which way you go, you'll get the same answer. The rule for that is changing the sign of x and the sign of y. So xy becomes negative x, negative y. Now m had both negative coordinates to begin with, so since I'm making them negative, they're both negative negatives, which makes them positives. N was a 0 for its x value, and I can't change the sign of 0, so 0 is just 0. And the negative 8 becomes negative negative 8, so positive 8. And the point 2, negative 2, becomes the point negative 2, positive 2. So I'll rotate this 180 degrees counterclockwise to create my image. And I'd like you to go ahead and pause the video and try this one on your own as well. Well, let's see how you did. 90-degree clockwise would be xy becomes y negative x. So P prime would be 7, 8, Q prime would be 1, 4, and R prime would be 9, 3. So this is the image after rotating 90 degrees clockwise. So let's try some examples of going the other direction. I show you a completed rotation, and you have to tell me how many degrees it rotated and in which direction. Now for this lesson, it's really pretty easy because all of the things I'm telling you today are rotations. But by our next lesson, we're going to be mixing rotations and reflections and translations, so it'll be a little bit harder to identify. But for today, we can at least get the basics that if I start at triangle STU, that's my pre-image because it doesn't have apostrophes, and I end at triangle S prime, T prime, U prime, well, I moved 1 quadrant away. 1 quadrant is worth 90 degrees, and I went counterclockwise. So this would be a rotation of 90 degrees counterclockwise. You can actually confirm that by looking at the coordinates of a pre-image and an image point. For example, S is the point 5, 9, and S prime is the point negative 9, positive 5. That follows the rule xy transforms into negative yx, which again matches to a 90-degree counterclockwise rotation. Or, like I said to begin with, it was rotated backwards 1 quadrant, which is equivalent to 90 degrees counterclockwise. Our next triangle has been rotated 2 quadrants away. So for that we would say it's a 180-degree either clockwise or counterclockwise rotation. Alternatively, you can look at corresponding points and compare their numbers. V is the point negative 10, positive 5, and V prime is the point 10, negative 5. So the numbers stayed in the same order, but they changed their signs. That matches to this rule for transformations, and that's the rule for 180-degree rotations. So I can say that this is a rotation 180 degrees around the origin. Go ahead and pause the video and try the next one on your own. This to me looks like a 90-degree counterclockwise rotation around the origin. I started here at triangle YAZ, and I rotated 90 degrees backwards, or 1 quadrant backwards, counter to the way the clock moves. So that's a 90-degree counterclockwise rotation, which you can confirm by looking at the coordinates. A is the point -2, -3. A prime is the point 3, -2. That follows the rule of xy transforms into -y positive x, and that's the rule for 90-degree counterclockwise rotations. Or, like I said, it just moved counter to the clock 90 degrees, or 1 quadrant away. And that's all you need to know about performing and describing rotations. In our next lesson, we'll do a review of how to identify any type of transformation that I show you based on looking at the graph. And then we'll start combining all of these transformations into one by doing compositions of transformations.